we're in sections 1.4 and it talks about composition of function. Before we begin, every time I discuss composition of functions, I always interested on the word composition. It reminds me of composite materials. There are many examples of composite materials. Fiberglass, the material on clothes iron, and last thing that caught my attention is bulletproof suit or Kevlar. And the bulletproof suit led me to this one, John Wick movie. Cool, isn't it? I know. So there's a scene where John Wick is getting ready for party, and the tailor begin to measure his suit party by asking, "What style?" "Italian." "How many buttons?" "Two." "Trousers?" "Taper." "How about the lining?" "Tactical." But that's not our part of our lessons. I just love to connect those things. Anyway, composite material is made by more than one material, or it consists of more than one material. Sandwich is also composite material. So instead of John Wick, you can tell other composite materials. I just want us to remind it every time we deal with the compositions of functions. You can, connect these compositions of functions with something, and not to John Wick only. So let's get into the lesson. Mister, please don't. Okay, we still need to go to the lesson. Next. Okay, so here we have John is a farmer. Now he is not a hitman. Each year, John plants seeds that turns into grapes. The function below gives the amount of grapes in kilogram G to produce if he plants grapes on A acres of land. So the A is a acres of land, while G is how many kilogram the grapes produce. G of A equal with 7,500, A minus 1,500. So if A equal with 1, then in 1 acre of land, then John will produce about 6,000 kilogram grapes. If 2, then that will be 15,000 minus 1,500, which is 13,500 kilogram, and so on. What John wants to know is how much money he will make from selling these grapes. So he used the following functions to predict the amount of money, M in rupiah, that he will earn from selling G kilogram. So M of G is equal with 9,000 G minus 50,000. So if he sell only 1 kilogram, then that will be 9,000 times with 1 minus 50,000. That will be negative 41,000. Yeah, negative 41,000. So he will get a loss if he only sell 1. So how much money that he could earn from selling the grapes? Let's find out. Okay, let's find the functions that can combine these two functions, okay, which call as a composition of function. So let me repeat it again. John wants to predict the amount of money, M in rupiah, that he will earn from selling G kilogram using the input A. Okay, so let me draw the flowchart for us so we will understand more. So this is the A, and John wants to put it to A G of, sorry, the G is supposed to be bigger, G of A, and then he will get the output G of A, and after he get the output G of A, then he will put it in the process of M of G in order to get M of G of A. Yeah. Now from here to here, this is what we call as the M composition G. Later you will be confused with OMG. Okay, M composition G. This is how we pronounce it. M composition G of A. It's same by having M of G of A. So how to get M of G of A? So M of G of A will be, first let's put G of A. What is G of A over here? G of A will be this 7500A minus 1500. So I'll put it 7500A minus 1500. Still remember about the f of x terminology? Then it's the same thing. If we have m of x, then this will be 9000x minus 50,000. If I have m of g, this will be 9000g minus 50,000, and so on. If I have m of 7500a minus 1500, then it will be 9000 times with 7500a minus 1500 minus 50,000. Okay, so that's what I'm about to write. 9000 times with 7500a minus 1500 minus 50,000, and let me check my answer. So that will be, whoa, that's a lot. That will be 67,500,000 of A minus 13,550,000 rupiah. Okay, so that's it. This also has a meaning. If John failed to produce on A acres of land, let's say A equal with 0, then he will have a loss of 13,550,000. If he get at least 1 acre of land, then he will get a profit. Yeah, quite good. Yeah, let's move to the next one. The next one, I'll take it from your book. So you may turn to your book page, let me see, on 1.4. So that will be page 29. Okay, so page 29, number 1. Okay, so let me read it for you. You shine a flashlight making a circular spot of light on the wall with radius 5 centimeter. Okay, so let me put it over here. Okay, so that's the circular spot on the wall with the radius of 5 centimeter. 5 centimeter. Okay, and then as you back away from the wall, as you step away from the wall, the radius increased at a rate of 7 centimeter per second. So that will be something like this. Okay, and then you step away again, and then you step away again, you know. So it increased by 7 centimeter per second. 7 centimeter per second. This is and then after 2 seconds it will be 14 centimeter, and then after 3 seconds it will be 21 centimeter, and so on. Yeah, so this is just to give you a clue. Okay, now A is find the radius at times 4 seconds and 7 seconds after you start backing away. So I'm going to try to answer number 1A, 4 seconds and 7 seconds. So 4 seconds, the radius after 4 seconds, that will be 5. Okay, because this is the first one, 5, and then add it with add it with 4 times with 7, so that will be 28 added with 5, 33. Yeah, 33. Okay, why I doubt. Okay, the 7 second, I'll leave that for you. B, use the radius of at times 4 seconds to find the area of the spot. So area of 4 seconds, then that will be pi times with the r of 4 seconds, yeah, square. Okay, remember, this is not r times with 4 square, this is like the r of 4. Okay, so I'll show you. That will be pi times with 33 square, and 33 square is about, wait, let me try to count it, equal with 1089 pi, yeah, to this one is the unit square. Sorry, does it say, oh, okay, centimeter square. Okay, but I'm interested on D. Okay, I'll leave C for you. Why can it be said that the area is a composite function of time? But I want to look at D problem. Let T be the number of seconds since you start backing away. Let R of T be the radius of the spotlight in centimeter. Let ART be the area of the spot in square centimeters. Write an equation for R of T as a function of T. Okay, write an equation for R of T as function of T. So R of T, that will be 5 added with 4 times with, sorry, not 4, added with 7 times with T. Let me get my eraser. 7 times with T. Yeah, I hope you do understand why the 5, it belongs to the origin one. Even on 0 second, you'll have 5. And then 7 times with T, it's from when you start backing away, the radius is increased by a rate of 7 centimeters per second. That's why you have this 7 times with T. And then A of R of T as a function of T. So A of R of T, this is the composition of function. So since we have pi times with the R square, and R square is R of T, then we'll have something like this. Okay, I'll put it over here, equal to pi times with, so then I'll substitute the R of T to this one, 5 plus 7T. 5 plus 7T square. So I'll have, yeah, I'll just have 5 plus 7T square times with pi. I'll just put it this way, yeah. Okay, let's check it. I mean, if we have A of 4 seconds like before, do we get the same thing? Then we'll have 5 plus with 7 times with 4 square times with pi, which is correct. 5 plus 7 times with 8 is 33. 33 square is 1089 pi centimeter square. This is just to verify. Okay, yeah. Now let's move to the next one. Now we want to move to the next one, which is the evaluate composite functions graph using graph and tables. This one is using graph. So in this graph, it provides us g of x, which is the blue one, and then we have the curve, which is the h of x over here. The question is, which of the following best approximate the value of g of h of 1? So this g composition of 1, but I'll put it g composition of h of 1 will be equal with g of h of 1. Okay, so what I need to do is to find h of 1 first. What is h of 1? So I will have the purple curve over here. H of 1 will be equal to 0 over here. So when the x is equal to 1, the h of 1 will be equal with 0. Okay, so I can change this. This is equal to 0. So then I'll have g of 0. What is g of 0? So then I'll look at the blue line over here. G of 0 happen when x is equal to 0. Okay, then I'll get the g of 0, which is negative 4. So you'll also get the same answer over here, negative 4, but the number it came from here, negative 4, because the x is equal to 0, then I'll get negative 4. So the answer for this is negative 4. Okay, let's move to the next one. Let's see it again one more. The graph of the equations y equal with f of x and y equal with g of x are shown in the grid below. Okay, which of the following best approximates the value of g of f of negative 2? So we need to find f of negative 2 first. F of negative 2 happen when the x is equal to negative 2, which is 0. Why everybody loves 0? Okay, so you have over here 0. What is g of 0? G of 0 happen when you have the x equal to 0, then you get negative 3. So this one will be equal to negative 3. As simple as that. Let's move. Okay, and we'll have evaluate compositions functions, same, but this one is using the tables. The tables below show some inputs and outputs of functions f and h. So we are asked to find h composition f of 1. I would love to put it this way, f of 1, and then we'll try to find f of 1 first. What is f of 1? So let's take a look on this table. Yeah, f of 1 will be negative 1. Yeah, f of 1 will be negative 1. So I'll use it as a h of negative 1. And then I'll get this. So the answer to this will be 0.5. One more. The tables below, for the table, yeah. The tables below show some inputs and outputs of functions f and g. We're asked to find g of f of negative 1 over here. So let's begin with f of negative 1. F of negative 1 happen when the x equal to negative 1 and the f of x will have a value of negative 6. Now from there we'll have, maybe I'm too fast, and negative 6, g of negative 6, when the x is equal to negative 6, g of x will be negative 10. Will be negative 10. Okay, so let's move to next one. Before we have 4 and 29, but I just erased that 1 second ago. I'm thinking if you have g of f of 2, and these are new questions. If you have g of f of 2, then you already know that f of 2 will be g of 3. Now you don't have g of 3 over here. When you try to look, hey, the number is just up to 2, so but you are asked to find it to up to 3, so you'll say over here that it's out of the domain. So this one will have no answer. Let's move to the new one. This is f of x equal with negative x squared plus 8x minus 4, and then g of x equal with 5 minus x. I want to compare f of g of x and g of f of x. Let's see. When we have f of g of x, then it will be f of 5 minus x. So we'll put f of 5 minus x into the equations negative, and then 5 minus x squared plus with 8, and then 5 minus x minus 4, and then we'll get over here negative 25 plus minus 10x plus x square plus with 40 minus 8x minus 4. Okay, and let's simplify this. Negative 25 plus 10x minus x square plus 40 minus 8x minus 4. Let's begin with the x square, negative x square, and then we'll have 10x minus 8x, that will be plus 2x, and we're going to have 40 minus 4 minus 25, that will be plus 11. Yeah, plus 11. So this is the f of g of x. Let's compare it with g of f of x. Okay, so we'll have over here, I'm going to erase this. Yeah, so g of f of x, f of x will be, yeah, g of negative x square plus 8x minus 4. So that will be 5 minus with negative x square plus 8x minus 4, and we'll have 5 plus x square minus 8x, and then plus with 4. So we'll have x square minus 8x, and then plus with 9. So you can see that f of g of x is different with g of f of x. Yeah, it's not always same. Now this one, this in algebraic form, it asks us to put it of f composition g composition of h of x. So we'll have f of compositions, I'll put it this way. Okay, every time you have this, try to put it in this way so you can trace it step by step. F of g, h of x will be 3x plus 5. Yeah, okay, from here 3x plus 5, substitute to this one, and then g of 3x plus 5. Yeah, then we'll just have f of over here 3x plus 5 square minus 1. Okay, so then we'll have a f of 9x square, and then plus with 30x plus with 25 minus 1 minus 24. Okay, and then f of g of x, okay, that will be 2, and then times with 9x square plus 30x minus 24 minus 2. Yeah, so I'll have 18x square plus with 60x minus 48 minus 2, and we'll have 18x square plus 60x minus 50. Okay, so if you have like f of g of h of I, yeah, same. This is not commutative property, so you cannot just have a f times with h and then times it with g. Okay, it's supposed to be in order. Remark for that one. Okay, next one, I'm going to have the advanced problem. Yeah, so this one I'll just leave you to think about how we can have this. So f of g of x is x squared minus 1. The g of x equal with x plus 3. What is the f of x? Okay, usually we are given g of x and f of x, but now you have to find f of x. Yeah, this one is using a let me give you a clue. This one is using inverse function. But number 2, you don't have to use the inverse function. This is a bit easier than the first one. F of g of x equal with 4x squared plus 2x, and you're given also f of x. Find g of x. This one, using composition of function, you'll be able to find g of x. Okay, so thank you for watching.